Now let's consider a numerical method for solving the Diriclet problem in case when we have the Laplace equation, and by using this discretization method or the discretization equation which we have proved earlier. So it was written in this form for the Laplace equation. We will make a grid, the complete area where we are trying to find the solution. In this this area we divide into small squares like this. We let's say that in this point we have origo, and we have the x-axis here and the y-axis here. So the length of each size of the length of of each square is h, both in x direction and y direction. So we are now considering points I, h, and g, h, where I and g are integers. And this is the x parameter and this is the y parameter. So for example, here in this case we have this pij is referring to these two I and j. So for example, p0, 0 equal to 0 times h, it's the x value 0 and the y value 0. So this is in, so p0, 0 is in this point. p0, 1 is just the coordinate 0 and h. Next, p1, 0 is just the coordinate h, 0. Here we have 2h, 0. Here we have, for example, here we have PHH, P11, sorry. So now you know what these points are. So we now make some simplification, or we make this symbol u, I, j, when we mean the value of u in the point with x value I, h and y value g, h. And by replacing x in this equation with hi and y by gh, we obtain the following. We see that x, here we have replaced x by I, h. We have done this all over, and we arrive at the following equation. So we get u I plus 1 h in the x value and gh in the y value. Note that we have made this symbol u h I is equal to this. So then u h plus 1 h gh must therefore be u I plus 1 g. And similarly here, this expression is simplified by u I j plus 1. So we end up with this symbolic equation. And we are going to use this symbolic equation to solve the Diriclet problem in this trivial case when we have here a given temperature on the boundary of a square. So in this square, which has side length 12 centimeters in x direction and y direction, we have the following boundary conditions. U is equal to 100 on this side, 100 on this side, and it's 100 on this side and 0 on this side. So we let now h be equal to 4 and make this grid. So we have in the coordinate system, we let this corner be equal to origo, and of course then we have the point P00. Here we have the point P10, P20, and so on. So using this equation we obtain several equations. Note that we have already the values on the boundary. So we start as follows. We note that there are only 4 points where the solution is unknown in these interior points. Let's start with writing the equation associated with this point when I and G both are 1 and 1. So I is 1 and G is 1. Replacing I with 1 in this equation and G with 1 in this equation, we obtain this equation. You see, U21, this is the same as this term. U12 is the same as this term, and Ui minus 1G, that is the same as U01. So U01, what's that? That's a value here. But in this case, we know the value in this point, so we just write 100 here. So what about this? U10. U10 is the value here. So we also know the value here. It's a yellow temperature, so to speak, the value of 100. So instead of writing U10, we just write 100, because we know this value. And minus 4 times U11. Let us do exactly the same for the next point, P21. So in this case, we replace I in this equation by 2 and G by 1. Then we obtain U I plus 1 G. What's that? Then we have U. Remember that I is equal to 2, so 2 plus 1 is 3. So it's 3,1. U31. And U31 is the value at this point. And in this point, the value is 100. So therefore we write 100 here. And the next we have Ui, which is 2, and G g is 1, so we have u2 2 in this point. So u2 2, where can we find that? That's u2 2. So we just write it because we don't know the value at this interior point. And we continue in the same manner. The next value is u11, and so we have this value. We have I equal to 2 and g equal to 1, so this value is the same as u2 0. And u2 0 is a yellow point, and at this yellow point the value is 100. So therefore we get 100 here. And minus 4 times uij, and I was 2 and g was 1. So then we have this equation. In the same manner we can write out the equations for each of these 4 interior points. So here we have done this. We showed you how to do it for the first 2 points, this and this point, and doing the same for the next 2 points, we get these 2 equations. And remember or observe that these are 4 equations with 4 unknown variables, and therefore we can solve this equation. And rearranging, one way to solve this is by using Gauss-Seidel iteration, and we will not go into the details here. It's linear algebra, and by solving this system of equations, we obtain that u11 is and u21 is equal to 87.5, and u12 is equal to u22 is equal to 62.5. So now we have solved this numerical problem with this discretization length h equal to 4 centimeters. Using smaller value of h, we get more equations, and we get a numerical result which is closer to the exact solution. So remember, this is not the exact solution, but it's an approximate solution of the actual problem.